the last section in Chapter 4 is a special types of applications where we're given table applications. We're given a table set, numerical table of values, where the values are almost linear. They're not perfectly linear, but they're kind of linear. And so what we're going to do is we're going to find the linear regression, what's called the best fit line. So we see an application that's asking you for the best fit line. In this class, that means linear regression. And so we're going to do that. It's all done on the calculator, so I'm going to run through the first example all on the graphing calculator. Alright, so all using our TI-83, TI-84, you should have a similar process. Alright, so my first example here is the year, the winner, and the prize money for the people who won the 500 Indianapolis 500 auto race. In 1977, the prize money was $1,117,000, and so on. Up till 93 is the last piece of information I have, which is $7,681,000. So based on that, I'm going to find the best fit line. Now first, I'm going to plug them into the calculator and do this. This is statistics, but I'm going to define my x and my y values. My x and my y are going to be my independent and dependent. Time is always independent. Now I'm going to do this where we typically in statistics, this is actually statistics. We usually let the time starting point be the first year of my piece of information. And so my time, which is going to represent my x value, is going to start at 0. So 1977 is my time 0. And so what I'm going to let my x value represent then is the years. After 1977, right? That's time 0. That's the first piece of information I have. And so that's how we let people know in statistics. The first piece of information came from 1977. That's our time 0, our initial year. And then we have information after that. And every year after that as well, the years after that. And so 81 would be 4 years later. 85 is 8. I believe it goes by 4s, 12, and 16. And so those are my x values. And so I had a table on your notes here. My x would represent 0, 4, 8, 12, and 16. My y's, I'm also going to change my y values. My y values are going to have to do with my prize, right? How much prize money depends on what year it was, right? Different years of different prize monies. But I'm not going to put my prize, and this is just a trickery the way we do it just to make graphing a little easier. Now you could leave the prize money exact. I'm not, because this is typically what we do in statistics. I'm going to let the prize money be the y value be the prize money. I got my whole word. But instead of writing it out completely, remember, every single prize dollar is rounded to the thousand, right? 100,000s place. And so that's what I'm going to do. I'm going to prize money in thousands of dollars. Which means 1,117,000. If I put it in thousand, that's going to be 1,117,000. And so that's what I'm going to use for my y value. So basically I'm dropping off those zeros. Just makes it a little easier to plug into the calculator. Now you, like I said, you could leave it. You would just have to make your window much bigger than what I'm going to make my window. But these are in thousands. Alright, so 1,117,000 does represent a million, right? 1,000 is a million. And those are the x and y values I'm going to use. Alright, so I'm going to use the x, which represents years after 1977. So year 0 is 1977. 4 years later is 1981. 8 years later is 1985. 16 years later is 1993. My prize money is in thousands of dollars. Right? So when I set it up, that's the way I set it up. So first thing, I'm going to construct the graph on the calculator. I'm going to do a scatter plot. Draw the points on my calculator. And we do this using the stat. This is statistics, and so we're going to use the stat key. And so I'm going to go to that stat key that we used when we found our one variable statistics. I'm going to go to edit. List 1 is going to be my x values. List 2 is going to be my y values. Alright, so I'm going to pop up my calculator. I'm going to go to stats. Over to edit. Not over to edit. Edit is the very first one. If I had anything in here, you'd clear them out. I don't, so I'm just going to go ahead and plug in my values. So list 1 are my x values, so my time 0, 4, 8, 12. Oops, not 1, 12. And 16. Alright, then my prize money, which I've got to be very careful when I type it in. 17, 1609, 3271, 5724. And then the last 17681. Alright, again, as long as I typed it in carefully. Then I'm going to go turn on a stat plot. And what you have to make sure you're careful after you do the stat plot, make sure you go turn it off, because sometimes with the calculator it messes up graphing later on. So turn it on and then turn it off. How you turn on a stat plot, if you look up here at the y equal, right above that says stat plot. So I'm going to hit second, y equal. All of mine are turned off, and once we do this, you'll want to go back in and turn them all off. I'm going to turn the first one on, so I'm going to pick 1. Alright, and so I'm going to hit on, and then type. I just want points. I don't want connected dots. I don't want a histogram. I just want points. So the first one should be highlighted. Then it should check, by default, it should say list 1 for your x values, list 2 for your y values. It doesn't, just change those. And then the bottom one is how your scatter plot's going to show your points. I like the first one because they're nice and big, so I'm going to leave it like that. Before I go to graph it, I am going to change my window. Right, so this would be a standard window. Well, I want to make sure I can see my points. Right, remember, my x values were my years. My years went from 0 to 16. Right, 0 to 16. I want to make sure I can see all of my years. And so I'm going to go leave a negative because I like to see, but I'm not going to do negative 10. I'm just going to do like negative 2. I think I did minus 2 instead of negative 2. Alright, so I can see my axis. You can start with 0 if you want to. And then I need to make sure, I like to go past 16. I don't want 16 to be on the edge of my page. So I'll probably do 20. Right, that way I can see my 16. Alright, y, I'm probably going to leave that negative 10. My y maximum, though, needs to be much, much bigger. And if you left yours in millions, you'd have to go up to millions. That's why I changed it to thousands, so I don't have to go to millions. And so my biggest y was 7,681. And so I probably just do 8,000. That'll make sure I can see everything. And then I'm going to scale by 200. Scale means scaling is just how many dash marks. So every 200 units, my dash marks are going to show up. If you don't scale it, that's fine. It'll just, the y-axis will just look like a blob of dash marks. Right, and then graph, and it should do, there's my scatter plot. Right, so there's all my points. So there's the first point at the year 1977. There's the second point 4 years later. The third, the fourth, and the fifth. And so that is, now I look at this and I should be able to answer my next question. So there's my scatter plot of my points. So there's that one. And so I now should be able to answer, does the data perfectly fall on a straight line? The answer is no. It's kind of a straight line, right? But it's not perfectly straight. It's kind of. Right, so what we do, well, no, the answer to that is no, it's not perfectly straight. So I'm going to find a line that best fits the data, meaning it's not going to be a perfect fit, but it's going to fit the data as best as we can. All right, which is, we do this a lot in statistics. We find the best way to make a prediction. The book shows the by hand method. We're not going to do the by hand method. So the Web of Science shows the by hand method. We're not going to do the by hand method. We're going to strictly use our calculator. All right, so this is all done on the calculator. So I'm going to go back to my calculator. Everything's already in there, and it's all done in the this is statistics. So it's all done in the stat key. So you go back to your stat. Now we're going to go over to calculate. And if you look down, the fourth one has LINREGAX plus B. That's linear regression. That's the best fit line. Best fit line is linear regression. And then it tells you ax plus b because it's a line. A is my slope, b is my y-intercept. And so you select linear regression, and then my calculator asks me for a bunch of things. If yours doesn't ask you for it, it by default has the x and the y values. So again, L1 should be the x, L2 should be y. There's no frequency, so if there is one there, clear it out. We're not going to store anything. We're going to go to calculate. All right, and then there it calculates. If you don't have your R's, it's not a big deal. I will never ask you for the R's. They're there to tell you how good of a fit it is, and I will talk about them, but we're not going to do anything with them other than me talking about them, what they mean. All right, but the big part is my slope is my A, which is 431.075. And it's just a coincidence those came out the same. It's just the way the numbers work. That won't happen very often. And they're actually not perfectly the same. They're off in the decimals. All right, so again, it's just a coincidence in this case. And so my best fit line was my slope was 431.075. X, and my y-intercept was 431.8, and that's my best fit line. Again, we use linear regression ax plus b in the stats key. Alright, linear regression. And there's my line that best fits my data. And so now I'm going to draw it and show you that the line is a good fit, but it's not perfect. So I'm going to draw it. And so I'm going to go plug that into my equation and look at it and say, and then we'll answer this. So we'll draw it together with the points that I already have on there, and we'll see if it does fit it well or not well. Alright, so I'm going to go to my y equal. I'm going to plug in that equation. So 431.075x. Plus 431.8 graph, and there's the best fit line. So you'll see only one of my points looks like it might be on the line. The rest of them are near it. So that goes to show you that they weren't perfect, but they are all kind of close to that line. And that is actually the line that best fits this information. Alright, so again, it's not a perfect fit, but it's a good fit. It is a pretty good fit. Alright, so it fits it. It's what we'll say is a good fit. It's a good fit. Alright, it fits it good. And that's actually what that R on the calculator is telling you. And we'll talk about that R in a little bit, how good of a fit it is. Alright, so there we've graphed it. It's a pretty good fit. And so now, since it's a pretty good fit, what we do in statistics, alright, we did this when we did probabilities, is we use statistics to make predictions. And so using my best fit line, I'm going to make a prediction about the prize money in 1998. It is just an estimate based on probability, or based on the best fit line, the linear regression equation. And so first of all, 1998 would be 21 years after 1977. So 21 is what I plug into my equation. So I plug it into that equation that I found, that 431.075x plus 431.8. And so again, 21 is going to go in there for the x value. And when it comes out, it's 9484.375. But again, since everything has been rounded to the thousand, remember this represents thousands. So $484,000, and so we would estimate, this is an estimate, that the prize money in 1998 is roughly $9,484,000. And again, it is just an estimate based on our statistical information. Well, slope is important. It's always important to understand what slope tells you in any equation, and what is it telling you in the linear equation. Well, it's an estimate, because it's our best fit. It's an estimate. So the slope is an estimate on how prize money is increasing per year. Alright, so based on our numbers, the prize money, our slope was 431.05. Remember, it's thousands of dollars. I'll write it better. The prize money was increasing, right, moving up, by about, right, it's an estimate, 431.075 thousand per year. So every year, an estimated, it's an average actually is what it is. It's an average increase. Based on our estimate, the prize money for this particular auto race increased on average by about $431,000 every year. That's what the slope was telling me. All right, now if you don't get an R, there is a way. If you don't have the correlation coefficient, you can Google how to get it. You have to turn something on or off on your calculator. Again, we don't use it, but if you want it, you can. There is a way to turn it on. You just need to Google how to do it if your calculator doesn't show you. All right, so our correlation coefficient was find it again because it's no longer on my home screen. The R was 0.979. And what the R tells me is it tells me about the fit. A perfect fit, so if we had a perfectly straight line, the R would either be 1 if it's increasing, or -1 if it's decreasing. So if I plugged in a perfect line where the points actually landed on a straight line, the R correlation coefficient would come out 1 or -1. -1 and 1 is a perfect fit. And so if R is close to 1 or -1, it's a good fit. The closer it is, the better the fit is. And so 0.979 is a pretty good fit. That's pretty close to 1. And so what we don't want to be is if R is close to 0, that's a bad fit. And really, anything much less than 0.9, we don't consider a very good estimator, a very good fit. We want it to be 0.9 or above for most of our applications. So again, 1 is a perfect fit, close to 1 or -1. Negative just means decreasing instead of increasing. If it's close to 0, so if it's like 0.5, 0.6, those would we consider poor fits. So we want it to be close to 0.9 or above in order for it to be a good fit. Alright, so that's an example. And we'll do some more of those. So we're going to do more linear regression in the next set of videos.